Hello everybody. Calculus part 4, continuity. First I will write the definition. Continuity definition. F of x is said to be continuous at a point at x equal to a if limit x goes to a, f of x equal to absolute value at x equal to a, f of a. Limit x goes to a, f of x means limit x goes to a minus f of x equal to limit x goes to a plus f of x. Now we will start the problems. Find the values of x, if any, at which f of x is not continuous. Problem 1. F of x equal to 2x plus 3 divided by x square plus 4. Solution. Clearly, x square plus 4 is not equal to 0 for all x belongs to real numbers. So, f of x is a real number. So, f of x is a real number for all x belongs to R. Therefore, f of x is continuous everywhere. Problem 2. F of x equal to 3x plus 2 divided by x square minus 4. Solution. In this problem, clearly, if x square minus 4 equal to 0, x square equal to minus 4, x equal to root 4, that is equal to x equal to plus or minus 2. So, f of x is undefined at x equal to minus 2 comma plus 2. Therefore, f of x is not continuous at x equal to minus 2, comma 2. Problem 3, f of x equal to 3 over x plus 2x by x plus 5. Here, solution x equal to 0, comma x plus 5 equal to 0. This implies x equal to minus 5. Clearly, f of x is undefined at two real numbers at x equal to 0, comma x equal to minus 5. Therefore, f of x is not continuous at x equal to 0, comma minus 5. For f of x equal to 2x plus 1 by 3x square plus x. 3x square plus x equal to 0. X into 3x plus 1 equal to 0. So x equal to 0 or 3x plus 1 equal to 0. This implies 3x equal to minus 1, x equal to minus 1 by 3. Clearly, f of x is not defined at two numbers x equal to 0, comma x equal to minus 1 by 3. So f of x is not continuous at x equal to 0, comma x equal to minus 1 by 3. Question number 5. F of x equal to 5 over 2x plus 3 over x square minus 1. Solution 2x equal to 0, x square minus 1 equal to 0. This implies x square equal to 1, x equal to root 1, x equal to plus or minus 1. F of x is undefined at x equal to 0. 2x equal to 0 means x equal to 0. 0 by 2 is 0, comma x equal to minus 1, comma x equal to plus 1. So f of x is Therefore, f of x is not continuous at x equal to 0, -1, comma, +1. Now, find the numbers at which f of x is continuous. Find the numbers at which f of x is discontinuous. At which of these numbers is f is continuous from the right, from the left, or neither? Which is the graph of f of x? So, problem 1. F of x equal to x cube if x is less than -1, minus x if -1 less than or equal to x less than 1, 2 by x if x more than or equal to 1. We have to check the continuity. We have to check the continuity of at x equal to -1 and x equal to +1. At x equal to -1, limit x goes to -1 minus f of x equal to limit x goes to -1 plus f of x. We have to verify this one. So if we take limit x goes to -1 minus less than -1 means x power 3 equal to limit x goes to -1 plus f of x. If it is more than or equal to 1, more than or equal to -1, we have to choose second function, that is minus x. So if you put value here, -1 power 3 here, this is equal to, if you put x equal to -1, the left hand limit equal to -1. This is the left hand limit. This is the right hand limit. This is the right hand limit. Right hand limit equal to minus of -1 is equal to +1. Left hand limit is not equal to right hand limit. So f of x is not continuous. F of x is not continuous at x equal to -1. We have to check continuity at x equal to 1. Left hand limit equal to right hand limit. We have to check limit x goes to 1 minus left hand limit equal to limit x goes to 1 minus f of x. This is equal to, if it is less than 1, according to the function, less than 1 is minus x. limit x goes to 1 minus x is equal to minus of minus 1 minus of 1 equal to minus 1. The right hand limit equal to limit x goes to 1 plus f of x. If x value more than 1, then we have to choose the last function 2 over x is equal to limit x goes to 1 plus 2 over x equal to 2. So left hand limit is not equal to right hand limit. Therefore, f of x is not continuous at x equal to 1. From the problem, they are asking at which of these numbers f is continuous from right or left or neither. Clearly, if you have x is less than 1 in left side of minus 1, f of x equal to x cube. X goes to minus 1 minus f of x equal to x cube. Clearly, f of x exists for all x belongs to R. Therefore, f of x is continuous from left of minus 1. If x goes to minus 1 plus, between minus 1 plus means the right of minus 1. Between minus 1 and 1, x belongs to minus 1 comma 1. F of x equal to minus x. F of x is not continuous from right of minus 1. Left of x equal to 1. Here, from the problem, f of x equal to minus x if x value minus 1 less than or equal to x less than 1. So f of x is continuous to the left of 1. Right of x equal to 1. That means if more than x more than 1, if x more than 1, f of x equal to 2 over x exists for all x belongs to R. Therefore, f of x is continuous to the right of 1. Now graph. We can draw the graph. Graph of f of x equal to x cube if x less than 1, minus x if minus 1 less than or equal to x less than 1, 2 over x if x more than or equal to 1. Now we can choose two values for a f of x equal to x cube. Y f of x equal to x cube. We choose two values less than 1. That is, less than 1 is minus 1 comma 0. If x equal to minus 1, f of x equal to minus 1. If x equal to 0, 0. We can choose one more value so that we can draw easily. Minus 2, this is minus 8. For f of x equal to minus x, between minus 1 and 1, we have to choose x value minus 1 and 0. If you put x equal to minus 1 is plus 1. If you put x equal to this is 0. The third function f of x equal to 2 over x. Between here, we have to choose x value more than or equal to 1. So if you put x value 1, this is 2. If you put x value 2, this is 1. For example, if you take x value 3, this is 2 by 3. So we can draw the picture. This is x, this is y, this is 0. Here, x value minus 1, x value 0 and x value 1. And you can make it 2 value here, 3 here. This is minus 2, minus 3 also. And here, if x value minus 1, for less than minus 1, less than here, the value would not take x equal to, sorry, this is x equal to less than minus 1. Less than minus 1 means minus 2. Minus 2, minus 8. Minus 3, minus 27. So if x value is minus 2, just down here. At x equal to 1, function value we don't know. This is the y equal to x power 3. From minus 1 to 1, it is a minus x means it is a straight line. Here minus 1 means plus 1. The x value here 1. This is 2. This is 3. First one value is here. And x value 0 means 0. if x value is if x value 1 does not exist, so this value here does not exist. It is a straight line. This is y equal to x. If x value more than 1 means here 2 over x more than 1, more than equal to 1. So at x equal to 1, y value is 2. So if x value 2, y value is 1. So this is y equal to 2x. So this is the graph. Problem number 2. F of x equal to e power x. If x less than or equal to 1, 4 minus x. If 1 less than x less than or equal to 4, x square if x more than 4. Solution. Clearly, we have to check the continuity at x equal to 1 and 4. At x equal to 1, you have to take left hand side, left hand limit x goes to 1 minus f of x. If it is x less than 1, limit x goes to 1 minus 3 power x is equal to 3. If it is right hand side, limit x goes to 1 plus f of x is equal to limit x goes to 1 plus 4 minus x equal to 4 minus 1 equal to 3. So limit x goes to 1, f of x exists equal to 3, and f of 1 equal to, if x equal to 1, that is 3 power x, 3 power 1. Therefore, f of x is continuous at x equal to 1. At x equal to 4, left hand limit. If you take left hand limit, f of x equal to limit x goes to 4 minus f of x equal to limit x goes to 4 minus, this is 4 minus x equal to 4 minus 4, this is equal to 0. If you take right hand limit x goes to 4 plus f of x is equal to limit x goes to 4 plus function equal to x square more than 4 x square is equal to 4 square equal to 16. So left hand limit is not equal to right hand limit. So Therefore, f of x is not continuous at x equal to 4. Clearly, f of x equal to x power 3, x less than or equal to 1. F of x exists for all x belongs to minus infinity to 1. Therefore, f of x is continuous to the left of 1. And f of x equal to 2 over x. F of x exists f of x exists for all x belongs to 4 comma infinity. Therefore, f of x is continuous to the right of 4. Graph f of x equal to 3 power x if x less than or equal to 1, 4 minus x if 1 less than x less than or equal to 4, x square if x more than 4. We choose two values to find y equal to 3 power x. For less than 1 means minus 1, 0, 1. If x equal to minus 1, 3 power minus 1 equal to 1 by 3. 3 power 0 equal to 1. And if x equal to 1, 3 power 1 equal to 3. For y equal to 4 minus x, it is a straight line, xy. We choose three values, x value between minus 1 and 4. We choose 2, 3, 4. If 2, 4 minus 2, 2. If 3, it is 1, 4 minus 4, 0. So, this third one, if the x value is more than 4, x, y. This is y equal to x square. It is a parabola. More than 4 means I take 5 and 6. 5 means 25. 4 means it is nearly 16, starting from 16. 6 means 36. So we can draw the picture. X, this is 0. First one, less than 1, here 1, 0, this is minus 1, 0, 1, 1, 2, 3, 4, 5, 6. This is y. This is 1, 2, 3, and so on. So this is minus 1, this is minus 2. If x value less than or equal to 1, so for 3 power x, if x value equal to 1, y value is 3, value is there, we have to make it full dark. 0 means 1, sorry, 0 means 1, 1 value means 3, so here x value minus 1, this is 1 by 3, this is the y equal to 3 power x less than or equal to 1. Here second function at x equal to 1, x equal to 1 undefined, so from here 2 means 2, three means 1, 4 means 0. Y equal to here third function f of x equal to x square. If it is a value is more than this one, actually it is 16 somewhere here up to it is going like this. Five means 25. From here around somewhere here 16, y equal to x square. That's all. Thank you very much.